8.4 tessellations. What are tessellations? A tessellation is a way to tile with shapes so that there's no overlapping and no gaps. So there's lots of different examples of tessellations. So we could have examples in the real world of the tiling pattern in some floors, or brickwork, or even the glasswork in some architectural structures. So what can we tessellate? So we can tessellate triangles. Each interior angle of an equilateral triangle is 60 degrees. So each angle is all 60 degrees. Because all the corners meet at a point, and those 6 corners all add up to 360 degrees, that means they can tessellate. So in the triangle example, we have 6 times 60, which is 360 degrees. In squares, if we look at the 4 corners within squares, what we have is we've got 4 lots of 90 degrees, which again gives us 360 degrees. And we should know that all the angles at a point, they all add to 360 degrees. So for tessellation to occur, we must have all the angles meeting to add up to 360. Now in a pentagon, all the angles are 108 degrees. So here we've got 3 times 108, which gives us 324 degrees. So therefore we can't tessellate regular pentagons together because it does not equal 360 degrees. Now what we might have to do then is, if we were to make it into a tessellating pattern, is we'd have to add in an isosceles triangle every now and again so that it would make it fit and make it fill in. But we couldn't tessellate with pentagons exclusively. So for tessellation to occur, the angles at a point must equal 360 degrees. So if we were to think of a honeycomb structure, it tessellates because the angles about a point add to 360 degrees. And that's because the interior angle for a hexagon is 120 degrees. And we multiply that by 3, we get 360. So at each point, we add to 360 degrees. So therefore, hexagons tessellate. And what we have here is an example of tessellation again, and that's because we can see that all the angles, so the ones that are vertically opposite are equal, and then angles in a straight line add up to a point, so therefore all the angles add up to 360 degrees. So the acute angles are the same as are the obtuse, and we've got that they all add up to 360, and we get this nice tessellating pattern. Again, all the angles at a point must add to 360 degrees so that there's no gap. So just some extra examples then to finish. How many sides does a regular polygon have if it's an interior angle of 160? Well, if the interior is 160, the exterior is 180 minus the interior, which is 180 minus 160, which is 20 degrees. Now we know that the exterior angle of a regular polygon is 360 divided by the number of sides. So the number of sides is 360 degrees divided by the exterior angle. So if we do 360 divided by 20, we get that the number of sides is 18. Example 2, determine if it's possible for a regular polygon to have an exterior angle of 20. So to do that, the exterior angle is 360 divided by n. So again, the number of sides is 360 divided by the exterior, which in this case would be 360 divided by 20, which is 18. So yes, it is possible. For 40, we'll do 360 divided by 40, which is 9. So yep, that's possible. Part C, we'll do 360 divided by 50. But that works out to be 7.2, so it's not a whole number, so it's not possible for 50. And finally D, we get 360 divided by 70, which works out to be 5.1428. So again, it's not a whole number, so therefore 70 is not possible. Our last example, find the value of x in this irregular hexagon. Well, what we need to do is work out the interior sum. To do that, we use the formula n minus 2 multiplied by 180, where n is the number of sides. So this is a hexagon, so it's got 6 sides, so it's 6 minus 2 times 180, which is 4 times 180 degrees, which is 720 degrees. Now if we add up all these angles inside, we'll have 2x plus 3x is 5x, plus another 3 is 8x, plus 4x is 12x, plus 2x is 16, plus 4 is 20x. So we've got 20x, and that must equal 720 degrees. So if we divide by 20, we get that 1x is equal to 36 degrees. So all the angles could be calculated using this x equals 36, but the value of x is just 36 degrees.